Greetings, my name is Marcus Gardner with www.adreamforbetterworld.com. This is the 5th video in the series called Working with Basic Fractions. In case you missed the first 4 videos, you can get them free at www.adreamforbetterworld.com. You may also get my free workbook from there as well. If you do not have the workbook, please stop this video and get it free from www.adreamforbetterworld.com. This video does have prerequisites. You must know how to add, subtract, multiply, and divide numbers. You will need to know the vocabulary in the workbook. Plus, you should have finished the problems from the workbook covering the first 4 videos. Also, this video needs you to have a strong understanding of taking the prime factorization of a number. Remember, it is never a good idea to learn new material until you are sure you are comfortable with the material you just learned. So please finish those problems from the other videos before continuing. If you have finished the prerequisites, then you are ready for this video. The workbook will help you a lot after you watch this video. So let's begin. This video will only cover the multiplication of 2 fractions like 5/8 times 2/15. So, how do you multiply 2 fractions? Take this problem for example, 5/8 times 2/15. How do we multiply them? Let's take a look. There are 3 basic ways that we can multiply 2 fractions. We will concentrate on the last way, but let's go ahead and talk about all 3 ways. The first way is what you have seen before in the videos when we are trying to get a common denominator. You just multiply across. 5 times 2 gives 10, then 8 times 15 gives 120. But we can reduce it to 1/12. Now before we did not reduce because we needed to add it to another fraction. But here we are done, so we reduce. The next 2 lines is using the same method. This is where we are trying to find out how we can reduce diagonally. Take a look at the second and third lines. Here we are trying to find a common factor between 5 and 15, or 2 and 8. Why can we do that? The answer is because we can do multiplication just like addition in either direction, like 5 times 2 or 2 times 5. So let's go back and explain exactly how we can cancel the 5 with the 15. As we learned in the first way, we can multiply across. So we have 5 times 2 and 8 times 15. But that is the same thing as 15 times 8. And if we go backwards, we have 5/15 times 2/8. So as you can see, we took the denominator from the second fraction and put it into the first fraction. Now look at the second line. We are taking the prime factorization of 15. We notice that 5 is in the numerator and the denominator. So let's take a 5 out. But before we do that, we need to remind ourselves that 5 is also 1 times 5. So if we take a 5 out, we still have a 1. So we have 5 on top and bottom. So take it out, and what is 5 over 5? It is 1. So then we get just 1/3 times 2/8 and get 2/24, which reduces to 1/12. Now even though we get our answer using that method, it is not the best way. The best way is the last method. Here we notice that 5 will go into 15 and 2 will go into 8, leaving us with 1 times 1 for the numerator and 4 times 3 for the denominator, which of course is 1/12. So the question becomes, can we always do that? The simple answer is yes, but it is easier if you break everything down into its prime factors. Take this problem for example. We could try to reduce step by step like this. We see that 12 and 54 are even, so we divide by 2. We also see that 245 and 35 end in 5, so they will both divide by 5. So now we see that 3 will divide both 6 and 27. We also see that 7 will go into 49. Then we are left with only 2 times 7 in the numerator and 9 in the denominator. So we get 14/9, which of course is 1 5/9. This will of course work no matter how big the fractions are. But it takes a lot of time. What if we just put everything into prime factorization? Take a look at how easy the problem becomes. We write 12 as 2 times 2 times 3, 35 as 5 times 7, 245 is 5 times 7 times 7, and finally 54 as 2 times 3 times 3 times 3. Then we just cross out all the primes that appear in the numerators and the denominators. We see a 2, 3, 5, and a 7 that are both in the numerator and the denominator, so we cancel them. Then our problem immediately reduces down to 14/9, which is 1 5/9. Now how about a problem that involves mixed fractions? The problem here is that some of my students will be tempted to try to reduce the 24 with the 44 and the 35 with the 25. A big mistake. You cannot do that because the 5 and 3 are part of the fraction since it is multiplication. Let's rewrite those fractions into improper fractions and you will see that we cannot do any reducing at all. Notice there is nothing that will reduce between 149 and 44, nor with 25 and 167. Now don't be tempted to say that you will never be able to reduce the multiplication of mixed fractions. Take this simple example. 1 1/3 times 4 1/2. You see, we can reduce a lot. Now your first statement might be, but you did not break it down into prime factorization like you just taught. Remember, there are always more than one way to solve a problem. No one method is the best for all problems. For this problem, I saw it was not necessary to break it down into prime factors. Please tackle that worksheet I have given you and try the problems a few different ways. Once you have solved all my problems, go back and create your own. For this, just randomly pick 2 numbers for denominators and any 2 numbers for the numerators and multiply them. The more you work on it, the better you will become and also the faster you'll become. Soon you will be able to get the prime factorization quickly, and then you can handle big fractions lightning fast by choosing different methods, whichever way is best for you. Okay, I think you know enough to tackle the second section of the problems on the workbook. Remember, no cheating. You will learn nothing if you look at the answers before you try the problems. Only look at the answers after you are done. Note, all answers in the back of the workbook are written out step by step. Once you have finished those problems, then you are ready to try the 6th video, dividing 2 fractions. Like this example, 1/2 divided by 1/8. Once you know how to multiply 2 fractions, learning to divide 2 fractions will be a piece of cake. I hope you have enjoyed this video. If you liked it, please tell others about it. If you have any comments, you may send them to me at comments@adreamforabetterworld.com. While it is free, I do hope you will consider making a donation to us so we can continue to keep making more of these videos. Please make your donation by using PayPal and using our email address donation@adreamforabetterworld.com. To use PayPal, just visit www.paypal.com. It is a free and safe service to send money. Thank you very much for watching.